Hello, this is Maths with Lemon, and in this topic we will see the probabilities, the basic concepts. We will start again with a universal set S. In probability theory, this is a set known as sample space. It contains here all the possible outcomes of a game, experiment, and so on. The subsets A and B of this sample space S are called events. Now, consider the sample space S here. The number of elements in S are denoted as NS here. This is the number of elements by total. So the probability of some event A is simply defined by the probability of A. It is n of my S, which is the number of elements, over the total. For example, if I have now in this diagram here, the Venn diagram, the sample space S, let's say that it contains 100 elements, all of it. All the elements in my sample space are 100. Whereas my A here set has 30. So basically, the probability of A, in simple words, provided that of course every element is equally likely to select it, the probability that this element belongs to A is 30 over how many I have, all of them, 100, which is basically 30%, or I can say 0.3. From here I can understand that the probability of an event, it should be less than 1 and of course bigger than 0. Probability of the 0 event is of course the opposite. Probability of non-event equals with 0, and the probability of my whole sample space should be 1. Now again, let's say that I have, let me select this space here. No, here. Okay, let's see it again. Let's erase these ones. If I want to see now the complementary events, the basic property from elementary set theory, here if A is the event, the complementary event, it's A stressed. So basically, if the probability of A here in my example is 0.3, then the probability of the complementary event will be 1, my sample space, minus the probability of the event A. So in this case, 1 minus 0.3, it's 0.7. The other one is if I'll have my, again, sample space here, let's make it. Again, I have my sample space S, and now I have two events, A and B happening, A and B. the basic property of combined events is n A union B, don't forget this is union, equals n A plus n B minus n of the intersection A B. So in probabilities I will have exactly the same, but with probabilities. So the probability of A union B will be probability of A plus the probability of B minus the probability of A intersection B. Let's have this example. My sample space is 100. This is probability 20 elements, 10 elements, and here I have 30. Obviously, all the other elements, it will be how much? 20 plus 10, 30, plus 30, 60. So outside I have 40 elements. So the probability of A is how many elements all the A set has? 20 plus 10. So it is 30 over 100, which is 0.3. The probability of B, all my set, is 30 plus 10 is 40 over 100, which is basically 0.4. And now here the probability of the intersection, which is this part here, how much is it? A intersection B is 10 over 100, which is 0.1. So how much is my probability of the union? What's the probability of selecting A or B? It is probability of A, which is 0.3, plus of B, 0.4, minus, now you see I selected 2 times 10, so I must remove the probability of the intersection, which is 0.1. So the probability is 0.6.